Welcome to the Kentucky Center for Mathematics. Today, we will be focusing on developing multiplicative thinking, and your host is Julie Adams. I look forward to learning from you, Julie.
All right, thanks. Good afternoon. Thanks for joining us today. I'm going to talk about developing this multiplicative thinking and sort of the foundations of multiplicative thinking and what that looks like. Hold on. Once you think you got everything figured out. I'm your host today, and this is my contact information. I work out of Morehead State University, which is, as Kelly said, in the eastern part of the state. We're going to want to touch on our website. There's a plethora of resources there. I'm going to show you some today, but our address is kentuckymathematics.org. You can find family resources there, professional learning, and all of our resources that we've been doing that are archived this week through professional learning over the internet, over Zoom. Today, we're going to take a look at the Kentucky academic standards in the early grades that are going to foster this multiplicative thinking. We're going to talk a lot about what it is, what it looks like, and the progression of this mathematical reasoning. And we're going to particularly focus on the counting strategies, moving towards additive strategies, and of course, multiplicative thinking. And we want to really dig in to what that looks like. And then I have some activities that are going to support multiplicative thinking. So hopefully I will stick to the agenda today and not get off. There's so much that I wanted to share that there's only so much in 30 minutes. So we're going to look at the particular standards that I'm going to try to focus on today are the second grade standards in operations and algebraic thinking of 20A3, which is determine whether a group of objects has an odd or even number, and then write an expression of that. And then 20A4, which use addition to find the total number of objects arranged in rectangular arrays with up to 5 rows and 5 columns. And then write an expression for sort of repeated addition for that, sum of equal add-ins. So that's what we're going to focus on today. Those two standards, as well as thinking about multiplicative thinking and actual definition of that and what it means. So I'd like to get started. With anybody like to open up to just have a discussion about what we think multiplicative thinking is? Anybody want to unmute?
For me, multiplicative thinking is being able to manipulate with numbers is in like composite units rather than by one. Being able to see, recognize those, and then be able to manipulate by using a collection of items.
So thinking about chunking and thinking about composite unit, maybe a composite unit within a composite unit?
Yeah, exactly.
Okay. Anybody else?
I think of it more as seeing something growing, like I'm 5 times bigger than I was when I was born or something.
Okay, so in a way of growing by unit, so multiplying in that sense. So thinking about, these are two separate definitions of multiplicative thinking. One came from Australia, and I'll just let you look through those as well. And another one sort of describe multiplicative thinking as the ability to work flexibly with concepts, strategies, and thinking about what that looks like and the representations of multiplication and division and how they occur. So I'm going to pause just a second. And if you'll notice, it says going beyond memorization of basic arithmetic skills. So that's what we want to focus on today. Is as teachers, how are we developing this progression of mathematical reasoning? And so I want to think about, I'm using Pamela Weber Harris's graphic of the development of mathematical reasoning. And I just want you to take a moment and pause and think, what do you notice? And I want you to think about, I want you to notice how the levels of reasoning, how they build on each other. And each kind of thinking and reasoning is based on the previous, and it's more complicated. And this development of mathematical reasoning graphic is an important piece of this hierarchy of mathematical progressive relationships or ways of thinking and reasoning. that build upon each other. And each way is a little bit more sophisticated than the prior one. And each of these ways of thinking and reasoning can be thought of as structuring or a way of schematizing, a way of viewing or dealing with mathematics. And we're going to call these sort of domains of thinking. And so I want you to think about what it means to you as a teacher role. And we're going to go over each one, what it looks like in accounting and additive and multiplicative reasoning. But I want you to think about how we can stretch our kids out of these different domains. So if they're counting, how we can get them to think additively, and if they're thinking additively, how can we make them think multiplicatively? And it based upon too often, sometimes we're well-meaning as teachers and we want to help students get the answers to questions, but because it's easier, they often use methods from a lower level of reasoning. So students get answers, but it doesn't necessarily change the way that they're thinking. And so sometimes these students they're stymied when they're expected to solve problems in the next level of more layer of complexity because they haven't developed the ability to think within that sophisticated mathematics. They just know how to get the answers. So for us, we as teachers, I think we need to understand the development of this mathematical reasoning so we can help our students think and reason in a way that's going to let them grow and learn. And so I want you to think about this a little bit more deeply today in the lens of, as a teacher, of how we're going to build upon what our students know and where we're going to take them to. So this development of reasoning. So I said that students need to develop each level of reasoning so they can build on the next one. And I want you to think about, again, it's not about getting answers to types of problems, but it's about how we're going to develop their thinking and reasoning. So we as mathematics teachers, we understand the hierarchy when we treat teaching mathematics as more than just helping students get the answers. So we're trying to help these students get these mental relationships and build these connections. And so we're changing literally the way the students think. But unfortunately, as a culture, we have misunderstood this progression. And we've seen how textbooks and standards call for students to add and subtract and then to multiply and divide, followed by with operating on fractions and decimals and percents and proportions, and then finally moving from algebra and functions. But we haven't focused on developing students who think in these ways. So we've allowed just for mere answer getting. And we've allowed students to rote memorize facts and mimic these procedures to find the answers without really focusing on moving from each level. So we need to focus on the level of reasoning and moving through these. So they're focused on the reasoning in a less sophisticated way of moving through these levels. So our goal is to think about how we can help kids develop as these multiplicative thinkers rather than just answer getting. And sometimes the answers are found using additive thinking and it's counterproductive. So they need to be thinking multiplicatively. So we want to think about the goal is not answers, the goal is focusing on development. So we don't need students who just can answer a multiplication problem, but we need students who can think and reason multiplicatively. So hopefully today we'll understand this progression and look at it and think about, so why is this important? So I'm going to show, this is a description of the progressions, and I want you to really think about what thinking lies in each progression.
All right, to make this a little bit more concrete, I want to pull together some research for you that I find very helpful in thinking about how to move kids from that place they're starting from. If I really want to see their work, how are you thinking about the problem? And then I want to move them to something more sophisticated. What is that more sophisticated? So this research has been helpful for me to pull together how do I want to nudge kids towards more sophistication. So this is a progression. If you look at these words up here, I've got counting strategies, to additive thinking, to multiplicative, to proportional, to algebraic. And this is meant to be sort of a progression of schematization that kids use when they think about problems. All right, so let's go through them just really quickly. If you were thinking about a counting strategy, then you might be solving a problem like, let's see, give me a division problem. I have 16 cookies and 4 kids. How many cookies do they get? Could a kindergartner or a first grade kid solve that problem? Okay, when teachers go like this, because you know they can, right? What would they do? They'd pull out 16 whatevers to stand for their cookies, and then they would divvy out those cookies until everybody got the same amount. Woo! Everybody's got that. what kind of strategy is that? It's division, so is that like multiplicative? Is that a division strategy? Or were they counting? They counted those 16 guys and they divvied them out one by one. That's a counting strategy. Let me give you another idea of a counting strategy. Middle school teachers, how many of you go into your middle school classroom? If you were to say to your students, hey guys, 58 plus 5. How many of your students would go? 59, 60, 61, 62. Is that a typical strategy for kids? What kind of strategy is that? I asked you 58 plus 5. That's an addition problem. Is that an additive strategy to go 58, 59, 60, 61? What kind of strategy is that? That's a counting strategy. That's noteworthy because it looks like a kid is being successful in addition when in fact they're using a counting strategy. And if they're still stuck in counting strategies, and they're not thinking additively, I'm going to have a really hard time getting them to think multiplicatively. And then you have a really hard time getting them to think proportionally. As middle school teachers, everybody smile, is where we want them in middle school, right? They need to be thinking proportionally. And so if I don't have these other steps, these precursors going on, then it can be very difficult for kids to think proportionally or multiplicatively or additively. So let me give you a quick example of what would additive thinking look like. So if I were to ask you that same question, I think I asked you 58 plus 5. If I were to ask you 58 plus 5, can you think of a different way to add 58 plus 5 using bigger chunks of numbers, bigger jumps of numbers? So I just heard somebody say, if you start on 58, then you could just add 2 to get to 60, and then how much more do you have left? You just have 3 left? That's an example of additive thinking, where you're using bigger jumps and bigger chunks of numbers. Yay, we're thinking additively, and that's huge. I need you to think additively in order to think multiplicatively. I'm going to give you a couple of examples of multiplicative thinking in just a minute. So if I want to move kids through these, oh, by the way, when do I want kids using counting strategies? Kindergarten, right? We're excited when they can count. We work a lot. Pre-K, we want to give those kids work. We love it when they learn to count. That's fabulous. First grade, you betcha. Use counting strategies. Really, by the end of first grade and second grade, we need kids thinking additively. We need to move them into additive thinking. Middle school teachers just went. Because they realize a lot of their students, 58 plus 5, are doing 58 A lot of their kids should have been out of those counting strategies by the time they are in second grade. So one of the pieces of my work is, what can you do with the kids at whatever level? If you're a third grade teacher and they're still using counting strategies, great, let's move them on to additive and multiplicative. If you're a middle school teacher and they're still using counting strategies, great, let's move them on to additive, multiplicative, and proportional. And what are the kinds of things that we can do to make that happen?
All right, so I want us to think about what are we going to do? So I think the point I wanted to make here is how kids move through these strategies. And I think that it's largely in part that we've misunderstood the development progression as educators. And thus we've just allowed students to just get the answers to problems and not use the reasoning from the previous levels. We haven't really talked with them about their reasoning and how they're getting the answers. And I really feel like that this is a piece that we're missing as educators. And so students may look successful at a level, but they do not have the mental schema to understand the next level. So at each stage, as teachers, we cannot be complacent with students solving problems and getting answers and use the reasoning of the level before. Instead, we have to ensure that we're going to assign them a task or an activity to develop more sophisticated thought so that they can continue to develop these more sophisticated notions of mathematics. So success is in each level is dependent on the previous, and and they're built upon each other. So wherever your kids are, even if they're in the 4th grade and they're still at a counting strategy, great. As teachers, it's our responsibility to think, okay, they're at a counting strategy. How can I move them to an additive strategy? And then how can I move them to think multiplicatively? So that's our focus. I want to think about as teachers, what can we do professionally, and how can we professionally notice kids in thinking about that? So one thing is I want to think about in reading, we do that all the time, right? As teachers of reading, we'll sit down with a kid and we'll talk to them about what they're reading. We listen to them read and we try to figure out where they are and what we can do for them. And we need to give math the same amount of time. So we need this interview portion in mathematics as well, so we can really understand where our kids are in this progression and how we can move them forward. So I want to think about, students are taught that addition is synonymous with traditional algorithms. So you can line the numbers up, add each column from left to right, small to big. So I want to think about what are some consequences about this. So students should be learning additive reasoning, but so if we're looking at 28 plus 12, what happens? So I want to think about if they use the traditional algorithm, they can at worst be summing up each of the columns counting by ones. So they can get answers using a counting strategy. With the algorithm, they can at best be using additive thinking, but only thinking about for single digits. So they never get a chance to think about the numbers 28 and 12, because the algorithm then when we stack them has them thinking about 8 plus 2 and then 2 plus 1 plus 1. So we need to work with students besides using the traditional algorithm. So students should be able to reason through bigger jumps of numbers, so that if we had another problem, such as, so if we had 28 plus 12, we might thinking about, well, 28 is about 30. And so I'm going to add 12 more to that. That'd be 42, but take off the 2 maybe that we already added there. So that type of reasoning in chunks is what we want kids to begin to think about. So this is this development of additive thinking. So also thinking about how in a multiplication problem, so we have here, students should be learning multiplicative reasoning, but when we think about 99 times 47, oftentimes we're still stuck down here in this array. So kids are still stuck in building this kind of one-to-one thinking. And then moving on to additive thinking, this is what it looks like. Maybe I'm gonna skip count in a sequence of chunks. And then to thinking about multiplicatively, what it might look like if I'm gonna distribute those chunks differently. I'm gonna stop there and think about, does anybody have any thoughts or that they'd like to share? All right. Oh.
Lots of loving the visual in the chat box. I just wanted you to know.
Okay, thank you.
That you took that visual through.
So I want to think about, I want you to think about, as a teacher, think about where your kids are and how you know where they are. All right, so we're going to look at sort of counting strategies versus additive strategies. So I'm going to let you look at this for a second. So what does it mean to use counting strategies to solve problems? Basically, counting strategies involve counting by ones, and here's examples of solving problems in thinking about what it looks like in all operations: addition, subtraction, multiplication, and division. I'm going to stop there so you can look at it. So thinking about, these are all examples of counting strategies, even though the student is finding answers even to multiplication and division problems, the student's brain is still thinking in terms of counting by ones. All right, let's take a look at the additive strategies. What does it mean to solve a problem using additive thinking? Okay, so additive thinking means that students solve problems using bigger amounts of numbers than just counting one at a time. So these are additive strategies, even though the student is finding, again, answers to multiplication and division problems, they're still doing it one group at a time. So that's additive.
Julie, there's a question about a student adding the tens and then shifting to counting by ones. And where might that live in these strategies?
Well, I think that thinking about moving towards bigger chunks. So even though we're chunking and then we're still counting by ones, so that might be in thinking about we're chunking, but we're still maybe chunking by ones, right? Is there a reason why we can't chunk that last little bit?
Yeah, I think Yeah, Julie, I think that's what a lot of teachers think. I think they think that as long as we're counting on, then that's an additive strategy, but really that's a counting strategy because you can hold that first collection, but that second collection is still a count by one strategy. So you're right, we need to look at them doing bigger chunks of counting versus still counting by ones, whether it's the first add-in or the second.
Thanks. And thank you for monitoring the chat. All right, so we're going to move on to what does it look like then using multiplicative thinking? So multiplicative thinking means that students are going to solve problems using bigger chunks than one group at a time. So I'm going to stop here and let you look through these.
Juliana, for some of us, the screen's a little bit blurry. You may want to pick out one or two of your favorites and just read it to us so we know it's on the screen.
Okay, I'm sorry. So this one says 7 times 59. I'm going to think of 7 as 59 sevens. So I know that 60 sevens is 420, but I only need 59 sevens. So 420 minus 7 is 413. And then another one, here's just one basic 7 times 8. It says I know that 7 sevens is 49, but I need 8 sevens, so I need one more 7. So 49 and 7 is 56. So still thinking about, these are multiplicative reasoning because the students are working with these bigger chunks than one group at a time. All right, so we want to think about how do we assess the student reasoning? So what does it mean to solve problems using additive thinking? What does it mean to solve problems using counting? So Pamela Harris, she's come up with just sort of a handout here. So if you're wondering how your students are reasoning, so that you can maybe ask them problems and see how they solve them, and it kind of gives a definition of what level they may be at. So I'm thinking about, I'm wondering if you're thinking about the kids in your classroom, and if you're thinking about, are you curious about maybe what level that they are they at counting, are they at additive, depending on you know, what grade that you teach, even thinking about that. Does anybody have anything they want to share, a thought? This is in your handouts if this slide is blurry. So it's just a reminder of you thinking about being curious about how your students are thinking, so we know that what level they're thinking. I know somebody commented, it is sad how many upper grade kids are stuck in counting, so that we need to think about, hopefully that we can give you some tasks that you can incorporate so that we're really focusing on their reasoning and moving them past these counting strategies. All right, so how do we do that? So we're going to really focus on developing multiplicative thinking, and we're going to do that by thinking about an introduction to arrays. And so on our website, I mentioned earlier that we have lots of resources. So one resource that we have here is an introduction to arrays PowerPoint. And this is something that you can use with your kids. And I'm going to escape out just for a second. I'm going to pull up the PowerPoint so you can see what it looks like. And we're going to go, I've fast forwarded through it just a little bit.
As we said, the PowerPoint is what's available to you through the print link. You can download that PowerPoint to your computer and use that in your classroom. The PowerPoint has an I can statement for the students to see, connection to the standards, as well as teacher directions. Here's a typical slide at this level 1 PowerPoint. We're going to think about a set model presentation where those sets are then pushed together to create an array. And then we're going to leave this array up for students to talk.
Okay, and then it just moves them through
out, and we're just going to really develop our language about what we see here. So here we see the teacher directions that are actually included in the PowerPoint that you can download. We're going to use open prompts such as tell me something about this picture. How many groups are there? How many cats are in each group, or in each row, or in each column? We're going to use and model that language of set, row, column, array, group, and then look for that language to be repeated back to us correctly from the students. So we have several different images in this PowerPoint so we can practice and explore that appropriate language.
Here's an example.
If you have a 10 by 10, 10 rows of 10 bead rack, this is very powerful for multiplication. We can think about building arrays using that bead rack. For instance, here we could see an example where...
Okay, I'm going to stop it right there. I just wanted to show you that this resource is available on our website. And so if you have questions about how am I going to introduce these, this is a great place to start. I'm using this PowerPoint, and it describes initially, we're not immediately asking them how many are in a group, how many total, we're asking them to describe what they see. And so this is something you can look at later to go step by step through how you might present this to your kids. And I've included a PDF of this in our resources. Also, I wanted to quickly think about some resources from our website. And I'm not sure, since we have a lot of people here that are from other states, if you know how to access the resources on our site. So I'm going to quickly go through some of the how that you would access those. So the KNPIG stands for Kentucky Numeracy Project Intervention Guide. And so if you'll notice, you can access it from our website, and it's kentuckymathematics.org. And then I'm going to scroll down. If you'll scroll down, the easiest way I can find it at the this is our webpage. If you scroll down to the very bottom of the page, you can see right here, KNP Intervention Guide. And when you click on that, it takes you straight to the intervention guide. You do need to type in your email and then a username and password. So the username is Bluegrass and the password is math. And then you can search the intervention guide. And I'm just going to quickly show you how you can search the guide. So you click on search. And the type of search that I'm going to do the standard search today. And the domain I'm going to use is operations and algebraic thinking, because that's what I want. And so the standard that I'm looking for today is 2083 and 2084. So I just simply choose those. And then these are the tasks that we have that are associated with that standard, to the development of that standard. So I'm going to show you on the PowerPoint. I'm just going to click on one really quickly. And I want to show you that the decimal point, it denotes the complexity level of the activity. So a 0.1 is going to be a little bit easier. 0.2 is going to grow in complexity. So I'm just going to click on one to show you what it looks like quickly. This is the one sorting even and odd counting cowboys. These arrows can get a little tricky. So if you just keep moving the arrows, you'll see that you can click on these lesson plans here and it'll take you straight to a lesson plan. This is a student printable instructions for a student, and then these are the printables that you're going to need for the activity. So you just click on those and it'll take you straight to that activity. The PowerPoint as well as that I just mentioned, played earlier, is on here. So let's just say I want to change the standard to 2084. Again, I change it like that. And then here's an activity that that I shared with you. One is called Shark Attack, and another one is called the Composite Cookie Company. And I'm just going to click on that to show you what it looks like. So here's the Composite Cookie Company. Again, there's the lesson plans, the student instructions. And when I click on that, it'll go that you have to save it. Sorry. And then this is what it looks like you'll print out. And the other one has the printables of the cookies and the recording sheet, if you'll click here, that you're going to need for that activity. So hopefully that will help you find some of the activities and the level that you want to focus on. So again, if you're at a different standard or a different fluency level, you can also search under fluency benchmarks as well. So this one is just a game for equal add-ins. So thinking about that second grade standard. And then this Composite Cookie Company, it has you print out some cookies, and then you're going to print out these cards. And it's going to tell you what to do. Get 12 cookies and share equally on the plate. how many on each plate and any left over. So again, we have lots of resources. This is another resource there. It talks about building arrays that's on our site. And it just guides you through how kids are going to build arrays on their bead racks and what that might look like. So thinking about just guides you through as a teacher for instructing students on how they're going to build their arrays and thinking about how you're going to determine who has the most beads. All right, so I want to think about another visual and a great thinking about a rich task that's going to involve kids from moving from additive thinking to multiplicative thinking. So this is a 3-act task from Graham Fletcher, and I'm just going to play it, just the introduction. If you're not familiar with his, you can go on the website, but there's 3 different acts that go in this rich task. So this is the first one. Oh, sorry. So he's just, I'm going to put an orange in there, and he's going to put some Unifix cubes in there that's going to equal the weight of the orange. And then the kids, they're going to get the information that each Unifix cube weighs 3 grams. So they're going to try to figure out how much the orange weighs. He goes through and he'll show it, the difference. But I wanted to focus on the reason why I chose this activity was because I found some student work that I wanted you to take a look at. And so these are ways, so I want you to think about the different stages that a child may be at as a teacher, and I want you to focus on how are we going to know what stage, are they at a counting stage, are they at an additive stage? So offering a rich task like this is going to let us know as teachers when we go around and we ask them how they found their answers, we're going to be able to think about what stage they're at. So if you'll just notice this student work here, I'm just going to say it's still at a counting stage. So even though they didn't figure out, they're still doing 3 plus 3 plus 3, and then they counted. So the teacher had asked them that. So instead of it may look like additive, this one was, again, one didn't get the correct answer, but there's some good work here. At least they're modeling that they weighed the orange, and then they're drawing the cubes that it took to weigh the orange. So just this is one classroom, and as you can see here, this is this child is thinking multiplicatively. They put the Unifix cubes in groups of 21. And so they knew that 3 times 21 was 165. So they're trying to develop different types. But I just want you to think about taking a look at student work and really analyzing what level your kids are. Here's another one. Thinking about the kid is using a direct model and is still counting by 3s, but then just jumps from 12 grams to 156 grams. But anyway, I just want you to think about being intentional as a teacher and offering them tasks where you can actually see and understand where they are. And I just wanted to show you where this came from. His website is gfletchy.com. There's lots of 3-act math tasks here. And if you'll notice, it's standard based. So here's the standard. And here's another one called fruit and nuts. And I just wanted to show you what it looks like. And this is the one, it uses a piece of this chocolate bar. And so it wants them to think about if the chocolate bar was this size, how many chunks would be in that bar. And if you'll notice a chocolate bar, if you'll think about what they look like, they're already in arrays. So there's Act 1, Act 2, and Act 3, and each one has a little video that you can show the kids to have them notice and wonder what mathematical thinking is going on there. All right. Another one of my favorite, I know I'm going quickly, but it's already past 2:30. This is one of my favorite websites, and I'm thinking about if I was a teacher, I would probably access this website and activities every day because it really brings out these images to support multiplicative thinking. And so I'm gonna go right there. And you can see it's called mathvisuals.wordpress.com. And if you look at multiplication and division, there's lots of activities. I love this one from Christy Newell. She developed a number talk. So we're still thinking about what is this dot, this dice dot pattern, what does it look like? And then what does it look like here? How many, how do you see them? And then we hopefully thinking about multiplicatively, how many now and how do you see them and what does it look like? So we can move from that visual of what it looks like. There's math flips. Again, lots of resources. I'm going to go down. I love this one, this multiplication kumquats. It arranges these in different ways, in different forms of arrays. And kids can compare what they look like. They can talk about it. There's lots there. I don't want to get into anybody else's presentation on into the weeds, but I did want to show you that there's lots of resources here, what it looks like on a bead rack. And I did share with you in the resources some cards, some multiplication flip cards, and I wanted to show you this multiplication printout of building arrays. So we have an L frame here so they can move it to show what it looks like on their bead rack. And then in the form of the multiplication table, what does it look like? So it has those beads numbered there so they can see that 7 times 9 is 63. And then it gives them, again, that visual of what it looks like. So another resource that I just thought, oh, this is so awesome. And there's so much there to share. All right, one more thing. This is another resource to support multiplicative thinking. This is again from Graham Fletcher, and it's Subitizing Cards. And I'm going to play it just for a minute so you can see the child's thinking and how the questions that you can ask them as a teacher to see how they're thinking. Oops, sorry.
All right, buddy, here you go. What's the product?
16, 15, 20, 32.
How do you get 32?
I know that 8 plus 8 equals 16 and 16 plus 16 equals 32.
Okay, all right.
18, 18, 24.
All right, nice. Okay, how did you do that one?
I did 6 plus 6 equals 12. 12 plus 12 equals 24.
And what do you also know that this is? You use additive thinking there.
I know that this is 6 times 4 or 4 times 6.
How are they the same and how are they different?
Right now, it would be 4 times 6 because there's 4 groups of 6.
Okay.
But if we switched it around and had 6 groups of 4, it'd be 6 times 4.
Okay, all right, perfect. Tell me about these cards here.
Well, this gives you a clue that all the rest of the numbers would be 4 in the boxes. It just doesn't show it. So this would be 16.
16, why 16?
Because 4 plus 4 equals 8 and 8 plus 8 equals 16.
All right.
Okay, I'm going to stop there. So hopefully you can see as a teacher, so we can, lots of times I feel like we give these games and we let the kids interact with each other. But I feel like that we really need to be there at a point to ask them what they're thinking and how they're solving the problems. So we can determine what level they are. This is another resource that I wanted to share with you. It just looks at these arrays and how they're the same or different. So this is in Google Slides. So you can pull this up. You can put different models of arrays on there. And even if you wanted kids to write on the whiteboard, these are the same because, and these are different because. So this is a resource that you can use, again, on Google Slides that I thought hopefully you may be able to spark some conversations with your kids virtually. I know, you know, we're teaching that way now. So thinking about posing 2 arrays and talking about how they're the same or different. Okay, so lastly, my favorite is illuminating multiplicative relationships that are found in nature. So this is a quote from Jo Bowler and her book, What's Math Got to Do with It? I love that book, but she talks about Mathematics is all about illuminating relationships, such as those found in shapes and nature. And we have to make it real world for kids. We have to live where they live, so that we can really open up their mind to thinking about these mathematical ideas and how they are in context of our real world every day. So thinking about, I just copied some off the internet that I saw. This building here, so it's a building, and if all of the floors were identical, so how many windows would be on the first floor? So even a kid, think about it, even if they were a counting strategy, we've took them a next step because we've screened some of it, right? So they can't see the back part of it. So that's another way to get them thinking about if they're moving from counting to additive, is we can screen part of it. So thinking about, you could ask them how many windows on one floor, how many windows on 2 floors, or how many windows would there be on 20 floors? So again, just ways that, and again, maybe you can reach them virtually with some of these visuals. I liked this one. It's just pasta noodles, but I like how it represents the equation that goes with it. Lots of times we don't think about what 0 of something is, 0 times 3, what that would look like. And so I love this blank space, so we can see, well, it's nothing, right? And then 1 times 3, that's what that looks like. And then when we have the whole, this part of the array, 2 times 3, and so on. I just like that. This is another example. I know you can't really see them, but these are Legos down here. And so this is a kid that has taken some toys and made the multiplication chart or table with Legos. And I love that. I love how they were thinking about that. This is just one animal here. So it's not, they didn't have a 1x1 Lego, obviously, but again, in their real world, that a kid created this on their own. And so that's really how they're thinking, and you can see how they're thinking about it. This was another activity involving Sour Patch Kids, and I always like to give an example of what is not an array. So lots of times we give examples of what is an array and what it looks like, but this one is, I'd like to pose it to kids and ask them, is it array? Is there a part of it that's an array, or could we make it into an array? So I like to offer kids non-examples so that we can have a discussion about why it is or is not an array, or how can we make it an array. All right, so hopefully now you're thinking about, as a teacher, where do you fit in the development of student reasoning here? Thinking about, how can we delay traditional algorithms? Our standards say we need to delay them for a while. We need to delay. But why do we go to those traditional algorithms instead of just developing their mathematical reasoning? And that's why typically that middle schoolers are still at the counting stage, is just because we mind these gaps ourselves. And so I want you to think about, how can you emphasize reasoning over rote memorization? And how can we really celebrate where students are while we're always working to further develop their knowledge and reasoning? So if you'd like to unmute, maybe, I know I'm way over time, I'm so sorry, and maybe share a thought or something that you're thinking about making a decision about or being intentional about as a teacher. There's no right or wrong answer, by the way. And maybe you're thinking about yourself. I sort of did that myself, and I'm thinking, how do I think about problems? Am I at a counting stage? Am I thinking multiplicatively? Or am I checking? Sometimes when I think about how I work problems, depending on my experience in the mathematical realm, sometimes I revert back to a less sophisticated strategy. All right, you guys are going to be quiet. I understand. Okay, so coming up, our virtual professional learning, we're still going to continue tomorrow. Dee's going to do the sequence of multiples, and then we're going to follow out this structure of numbers multiplicatively later on throughout the week until we're monitoring and assessing multiplication. And then another shout out to our website and how you can get there, and then you can go straight to our website for our virtual meetings, and you can click on there, and that's how you can attend the live session. And again, here's my contact information. I thank you for learning with me today, and I hope that you found some of the information valuable, and I hope that I've sparked a little maybe personal reflection, or maybe inspired you to change your teaching and offer some visuals for multiplication and thinking about moving these kids through the progression. So thanks for being with us today.
So we always thank our host, Julie, and she's put a lot of time and effort into really a really nice progression of entry into what is multiplicative thinking. So Julie, you gave us a lot to think about today with regards to how K-1-2 really builds that and how it builds from counting. We really do value your input. And so if you want to unmute yourself and just kind of mention, what was your favorite part about the things that Julie showed us today?
I don't know if you can hear me, but I was just going to say that one of the things I really liked going into next year, I actually teach 4th grade, but we all know that we are going to need to back up and fill in some gaps. And I think the tools that this has, especially with the 3-step like ask and wonder type questions, just can build their thinking. And, you know, there could be a good chance that they don't have, you know, maybe they won't hang on to a right and wrong answer because many of them may not have that right and wrong. Sorry, I finally got my video on. That right and wrong idea where they have been gone so long. So this kind of is a perfect time to build a bridge between old information and new. And also to do away with some of their wanting to be right, because it seems like everybody is probably going to have a little bit of shaky ground when we start back next year. So, just a thought.
Brandy, I like that you gleaned from that entry point, thinking about, are they, because as a 4th grade teacher, are they multiplicative yet? Or are they just additive? Right? Have they gotten to that multiplicative thinking? So I think you've got a great beginning for a way that you can kind of assess your kids as they're coming in.
And I think it's important to kids that they know that they can progress through these thought processes, because we present them with a multiplication problem and they just freeze. They don't even think about, you know, sometimes I want to think about, yeah, you can count if you need to, right? It's just that we've set them up for this thinking that if I don't know the answer right away, that, you know, I don't have an entry point to this problem. So just thinking about continually supporting them and interviewing them as a teacher and really knowing what their thought process and where they're coming from. And then thinking about how we're going to support that with tasks that we're going to ask them, or activities.
I was going to add that as someone that taught middle school for a very long time, lots of middle schoolers show up at 6th grade actually doing counting strategies instead of, you know, multiplicative, where we're trying to be thinking about proportions. And so it is very helpful to have ways to help students work through, use the skills that they have to work through grade level problems. And so actually really understanding this progression of student reasoning is super helpful in no matter what grade level you teach. You will have kids all over the place in that continuum, and you can have, you know, have them explain to you how they're thinking, and that helps you know where they are and where to go.
Thank you for showing how to navigate the Kentucky website. I was shown at Math Recovery, but kind of had forgotten. And so I've been looking for things, and now I had, oh yeah, there is a better way to do this, because I was looking for that AVMR version for some of the things I'm looking for.
Yeah, and you can definitely search by that, or again, by fluency benchmark, if you'd like, or you can search through AVMR activities. And also you can search by setting. If you just have dice or popsicle sticks or whatever, you can just search, you can choose search by setting and just put in some manipulatives that you have, and it'll come up all the activities that we have that go with that particular manipulative. So that's helpful too as well. If you're looking for bead rack activities, you can't think of how to search or what standard it might be, you can just type in bead rack.
So Julie, as always, you do a great job. You give us lots to think about. People love seeing the student works. I personally loved hearing students. I've missed their sound. I missed the sound of their voice, and that was fun to hear kids talking about mathematics. She was really doing a great job with those math cards. So the Kentucky Center for Mathematics, we have a Zoom session every afternoon at 2 o'clock. Tomorrow is part 2 of this. You see us on social media. Follow us on Facebook, follow us on Twitter, and we'll see you tomorrow at 2. Bye, guys. Thank you, Julie.